Naming hydrocarbons 2 continues on from number 1, and this time we're looking at branched and cyclic chain hydrocarbons. So a branched hydrocarbon is when we have carbon atoms coming off a central carbon chain, like we see here, coming off this central carbon atom, okay? So in naming them, what we do is we start off by counting the number of carbons in the longest carbon chain, okay? In this case, we have 6 carbon atoms in our longest carbon chain, okay? This means there will be hex somewhere in the name, like we learnt from the last video, okay? Then we need to account for our branch, okay? This thing coming off here. To do that, we're going to introduce a new table to help us name the branch. So if there's 1 carbon atom in the branch, it is a methyl group, and the prefix will be methyl. 2 carbon atoms, ethyl group, ethyl. 3 carbon atoms, propyl group, propyl. So we see here we have a methyl group coming off of carbon number 2, okay? In our name, this means we say 2-methyl to indicate the methyl group coming off the 2, and then hexane, like we learnt in the last video, that otherwise it is a 6-carbon alkane, okay? And then obviously the extra carbon in the branch. Here we have a similar example where we have an ethyl chain, okay, an ethyl group coming off of carbon number 2. Again, we have a 6-carbon chain, same as the last one. However, there are 2 carbons in our branch, so this time it's an ethyl group. So again, it's off of carbon 2, therefore our name will be 2-ethyl hexane. Okay, very similar to the last one, just we have an ethyl group on carbon 2. There are branched hydrocarbons that have more than 1 branch, like we see in these examples here. Okay, however, in the naming, again, we start with by counting the number of carbon atoms in the longest carbon chain. Here we have a 5-carbon long, longest carbon chain, therefore from the last video we know pent will be in the name. We also have 2 methyl groups, 1 on carbon 2 and 1 on carbon 3. This means on our name we have 2, 3, for carbon 2 and carbon 3, dimethyl pentane. So it's dimethyl because there are 2 methyl groups, carbon 2 and carbon 3, and then pentane, which is the stem. Another example here, we have 7 carbons in our longest carbon chain, and we have 3 ethyl groups, okay, 2 carbons long. This means that we have 2, 3, 5 triethyl heptane. Okay, explaining that, the triethyls, 3 ethyls, are on carbons 2, 3, and 5. 2, 3, and 5. This is what gives us our 2, 3, 5 triethyl. And then again, heptane is simply the stem, a 7-carbon stem. Okay, this is quite a scary looking example, but we can name it easily just by going through the same steps that we've been going through before. Okay, so we'll start with counting the number of carbon atoms in our longest carbon chain. We have 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms in our longest carbon chain, making it an oct chain. Okay, we also see we have a double bond on our longest chain, located on carbon 2. This means it's an alkene, and with the double bond on carbon 2, for our central carbon chain, we have oct-2-ene. Okay, so we know that from the off. Now looking at our branches, we have a methyl group on carbon 2, and a methyl group on carbon 5, and we also have an ethyl group on carbon 4. So we have different lengths of chains on our branched hydrocarbon. So revealing the name now, we have 4-ethyl 2,5-dimethyl oct-2-ene. Okay, so a horrible long name, however, we can easily explain it by an ethyl group being on carbon 4, and we put ethyl first because it is before methyl alphabetically. 2,5-dimethyl, 2 methyl groups located on carbons 2 and carbons 5, and then oct-2-ene, which is our base chain which we explained at the start. Okay, here's an example for you to have a go at. So just using the same instructions as before, the same steps, just pause the video and unpause when you're ready for the answer. Okay, revealing the answer now. This compound is 2,5-diethyl 4-methyl oct-3-ene. Okay? So to explain this, we have a 1, 2, 3, 4, 5, 6, 7, 8 carbon long chain with a double bond located on carbon 3, hence the 3-ene. So oct-3-ene, that's the base chain. We also have a methyl group on carbon 4, the 4-methyl, and ethyl groups on carbons 2 and carbons 5. Okay? Hence the 2,5-diethyl. And because E is before N in the alphabet, alphabetically, ethyl will come before. So now we're going to talk about the naming of cyclic hydrocarbons, which is a far easier concept than branched hydrocarbons that we were talking about before. Okay? So cyclic hydrocarbons, as you should know, are a ring structure. They form a ring structure. So here we have a 1, 2, 3, 4, 5 hydrocarbon ring. So we'd assume pent to be in the name, which it is. However, even though this is an alkane, we cannot call it pentane because we won't be able to differentiate between a linear pentane. Okay? Therefore, we simply call this molecule cyclopentane. Okay? So to indicate it's a cyclic hydrocarbon. Okay, here we have an example with a cyclic alkene. Okay, we can know it's an alkene because of the double bond, and this particular cyclic alkene has 6 carbon atoms in. Okay, 6 carbon atoms. We see hex in our naming table, and therefore the name of it is simply cyclohexene. So comparing this to a linear hexene, hex-2-ene, if the double bond is on carbon 2 to carbon 3, we can't indicate which carbons the double bond is in between on our cyclohexene because being a ring, there is no start to the molecule, so we don't know where to start numbering the carbons from. Okay? So we don't have to indicate a position of the double bond as we do in linear when it is a cyclic alkene. Okay? So that's all for this video. I hope it's been helpful, and we'll see you at the next one.